and welcome to this lesson. In this lesson, we are looking at perpendicular vectors. This is a build-up on what we've been doing so far. So we started with multiplication of vectors, we moved on to parallel vectors, and today we are on perpendicular vectors. Perpendicular vectors are also known as orthogonal vectors. Orthogonal vectors. So you might hear the name perpendicular vectors, or you might also hear orthogonal vectors. Now, what are perpendicular vectors? Perpendicular vectors, they are vectors that meet at 90 degrees. So, if I have a vector A and I have another vector B, and they are meeting at 90 degrees, which is a right angle, it means these two vectors A and B, they are what? Perpendicular. Two vectors are perpendicular, or two or more vectors are perpendicular if they meet at 90 degrees. Now 90 degrees is the inner angle. If you look at the outer angle, this will be 270 degrees. Why? Because this is 90 degrees, and we know that at a point the sum of all the angles there is 360. So if they meet at 90 degrees, what it means is that what angle do you add to 90 degrees to get 360 degrees? And that is 270 degrees. So we can also say that perpendicular vectors or orthogonal vectors, they are vectors that meet at 90 degrees or 270 degrees. They are vectors that meet at 90 degrees or 270 degrees. Now, what are some of the conditions, or what are some of the properties of perpendicular vectors? The first thing is that they meet at 90 degrees. They meet at 90 degrees or 270 degrees. The second thing is that their dot product is equal to 0. Yes, so we did multiplication of vectors. For perpendicular vectors, whenever you multiply the two vectors using the dot product, you always get 0. The dot product of perpendicular vectors will always be 0. Number 3, the product of their gradient will always be -1. The product of their gradient will always be -1. The product of their gradient will always be -1. The fourth one is coming from this. The gradient of one vector will be the negative reciprocal of the other vector. The gradient of one vector will be the negative reciprocal of the other vector. So, gradient of one vector is equal to the negative reciprocal of the other. Now, what do we mean by the gradient of one will be the negative reciprocal of the other. So if I have vector A and vector A has a gradient of 3 over 5 and given that B is perpendicular to A, which has a gradient of 3 over 5, it means B will have a gradient of, now you interchange the positions. The denominator comes up and then the numerator comes down, which is 3. After that, you add negative to it. So it means that the gradient of the first vector, which is 3 over 5, is the negative reciprocal of the second one, or the second one is a negative reciprocal of the first one. So there's one property. Now you recall that I said when you multiply the gradient of two orthogonal vectors or two perpendicular vectors, you always get negative 1. Remember, if you multiply the gradient of two perpendicular vectors, you will get negative 1. So A and B are perpendicular. So let's multiply their gradient and see. 3 over 5 by negative 5 over 3. Shall we? 3 cancels 3. That will be 1 and 1. 5 goes into 5. That will be 1 and 1. So 1 by negative 1 will give you negative 1. 1 over 1. 1 times 1 will give you 1, which is 1. And this will be negative 1. So whenever you multiply the gradient of two perpendicular vectors, you always get negative 1. Now, we have this question. Write two vectors that are perpendicular to A. We have 2, 3, and B, we have negative 1, 8. So, let's start from the first one, A. Now you were given 2, 3. 2, 3. If you want vectors that are perpendicular to this, what you do is that the first one will be you write the vectors, you interchange their positions. So this becomes 3. You interchange the positions. So the 3 comes to the top and then the 2 comes to the bottom. Are you following? You have the 3 coming to the top and then the 2 coming to the bottom. When you are done, you add negative to one of them. Not both, but one. You can decide to add it to this one. So this is the first one. This vector is perpendicular to this vector. The other vector that is also perpendicular to this is, so still you interchange the positions. So you have 3 here and you have 2 here. Now because you've added a negative to this, you add a negative to the other one. These are the two vectors that are perpendicular to this given vector. There are more, but the basic ones is what we are doing. Now, the second question, which is the B, we have negative 1 and 8. Negative 1 and 8. What's the first vector? That is perpendicular to this. The first vector that is perpendicular to this is, so 8, which was at the bottom, comes to the top, and then the negative 1 comes to the bottom. Now we will add negative to one of them. So let's start from here. So negative 8, negative 1 is perpendicular to this given vector. The other vector that is perpendicular to this given vector will be, so I have 8 and -1. Because I added the 8 to the x component, the second one I'll add the negative to the y component. So here becomes a double negative. And double negatives are always what? Positive. So vectors that are perpendicular to -1, 8 are -8, -1, and 8 and 1. They are all perpendicular to the given vector. This is your activity. Write two vectors that are perpendicular to, so 4, 5, which is the A, and B, which is -6, 10. This is your activity. Take your time and solve it step by step. Investigate if A is equal to 4, 8, and B is equal to 8, -4 are orthogonal. Investigate. What does it mean? It means tell whether vector A, which is 4, 8, and vector B, which is 8, -4, are perpendicular. Yes. How do you know? How do you know the two vectors are perpendicular? So, our solution. When two vectors are perpendicular, it means their dot product is 0. Their dot product is 0. What it means is that when you multiply the two vectors, you get 0. So we will multiply vector A by vector B. If the answer we get is 0, it means the two vectors are perpendicular. Or if we get any other answer apart from 0, then the two vectors are not perpendicular. So we have A. This vector A, which is 4, 8, can also be written as 4, 8. And the vector B can also be written as 8, -4, like this. Now let's multiply. A dot B, how do we multiply? So A is 4, 8, multiplying B, which is what? 8, -4, like this. So you multiply the x component 4 times 8. 4 times 8. So you have 4 times 8. Then you add the 2. 8 times -4. 8 times -4. Now 4 by 8 will give you 32 plus 8 by -4 will give you -32. So this will be 32 minus 32. And what's the answer? We are getting 0. So because we got the dot product to be 0, we can conclude that therefore A and B are perpendicular. As simple as that, and we are done. So this is one way of checking if two vectors are perpendicular or not. 2, 2, -4. Which of the following vectors A, B, and C, which of them is or are perpendicular to 2, -4? So you have to check. The simplest way is to use their dot product or to multiply the two vectors. The simplest way is to multiply the two vectors. So solution. Let's compare the given vector to this vector to this. So we have 2, -4. Let's multiply it to this, which is 6, 8. If you multiply, what do you get? So 2 will multiply 6, and that will give you 12. Then you add it to negative 4 by 8, which is negative 4 by 8. This will be equal to 12 minus 32. 12 minus 32, and that will be negative 20. So because we didn't get 0, it means the two vectors are not what? Perpendicular. They are not perpendicular. Now the second one. Let's take, so this is not. Let's take 2 negative 4 and multiply it by 12, 6, like this. Okay, so 2 by 12 will give us 24. We add it to negative 4 by 6. That will give you negative 24. And that is 24 minus 24. So the answer is 0. Because we've gotten 0 here, it means this vector B is perpendicular to negative 4. So this is perpendicular. For the third vector, we will take the vector negative 10, negative 5 and compare it to 2, negative 4. So we will multiply the 2, negative 4 by negative 10, negative 5. We will multiply. 2 will multiply negative 10. That will give you negative 20. Then negative 4 will multiply negative 5. That will give you positive 20. So you add everything. You have negative 20 plus 20, which will give you what? 0. This means that our vector C is also perpendicular to our vector that was given to us, or our reference vector. So in conclusion, 12, 6, vector 12, 6 and vector negative 10, negative 5 are perpendicular to vector 2, negative 4. Given vector A equal to 2, 2 and B equal to m negative 5 are perpendicular, find the value of m. Find the value of m. We've been told that the vectors are perpendicular. So our solution, because they are perpendicular, it means that when we multiply the two vectors, we will get what? 0. We will get 0. Alright. So our A is 2, 2. And our B is m negative 5. But this would give us 0. So it means that 2 times m, 2m, we are multiplying this 2 multiply this m, 2m, then 2 times negative 5, that will be negative 10 is equal to 0. Now I have 2m minus 10 is equal to 0. What do? 2m will be equal to 10. 2m will be equal to 10. You divide both sides by 2. Both sides by 2. It means that our m is equal to 10 over 2, which is 5. So this is how you solve questions like this. Now, we will take our last example and then we are done for this lesson. Okay. Given that m and n are perpendicular, given that vector m and vector n are perpendicular, find the value of y. Find the value of y. So we are given m to be equal to 3, y plus 6 and n equal to y negative 10. Our solution. Okay, so what do we do? Because they are perpendicular, we know that their dot product will be equal to 0. So our m, which is 3y plus 6, multiplying n, which is y negative 10, should give us 0. Now 3 will multiply y, which means you will get 3y. Then this y plus 6 will multiply negative 10. So I'll bring the negative 10 first, and I'll multiply it by y plus 6, and this should be equal to 0. Okay, so I have 3y. Negative 10 by y will give you negative 10y. Then negative 10 by 6 will give you negative 60, and this should be equal to 0. Okay, 3 minus 10y should give you negative 7y minus 60, and this is equal to 0. Yes, so I have negative 7y to be equal to 60. You divide both sides by negative 7, both sides by negative 7. This cancels this, so I have y to be equal to, we have 7 will go into 60, that will be 8 times. That 8 times will be 56, so it will be left with 4 over 7, which is negative. So it means that the value of y for which these two vectors are perpendicular is negative 8 whole number 4 over 7. 4 over 7. So soon, we've come to the end of this lesson. This lesson comes with an online quiz. The link will be in the comment or the description of this video, and you can access yourself on the concept you've learned so far. Thank you, and I'll see you in the next lesson.